All right, well, good afternoon, everyone, and welcome to the May Conditions and Outlooks briefing. I'm Tony Bergantino, Director of the Wyoming State Climate Office and the Water Resources Data System. And this webinar is being presented by my office, the USDA Northern Plains Climate Hub and University of Wyoming Extension, the US Geological Survey, US Bureau of Reclamation, the National Weather Service office in Riverton, and the National Weather Service Colorado Basin River Forecast Center, or system this month. This briefing will go over some current drought, climate conditions, surface water status, reservoir storage and such, and then we'll take a look forward with weather, river forecasts and outlooks, and then we'll have our featured product. The USGS will talk about the gauge to page. So let's start off with the current conditions, and this is the current drought monitor map. Came out this morning and shows where we're at as of Tuesday, the 23rd of this week. We're continuing to see some improvements thanks to that widespread precipitation we saw earlier in the month. Unfortunately, the precipitation wasn't as widespread as it could have been, and it also didn't continue as much as it could have also. So we have been seeing some degradations, especially up in the Northwest, which missed out on a bunch of the precip, and so we have some dryness starting to emerge there again. Looking at the timelines, here's the updated timeline showing how much of Wyoming is in each drought category from the year 2000 to present, which is when the drought monitor started. I didn't mention it on the previous slide, so I wonder if anyone out there really noticed anything different about that map. This is the 26th monthly conditions briefing that we've given, and this is the first one where there was no extreme drought or D3 on that map. So as a result of that precip earlier this month, especially in the east, the drought map for last week was the first one in 147 weeks not to show any extreme drought in Wyoming. So that was a nice milestone. Just over 19% of the state is in the D1 to D4 category. That's the actual drought category. And as I always point out, the D0 is not drought per se, but it's what we call abnormally dry and just sort of a heads up condition that we're either getting into some dry conditions or maybe we're coming out of an area that was in actual drought. That 19, actually 18.53 to be exact percent, is a decrease of 12.77% since the last webinar. So we continue to see improvement overall. Even with the latest degradation there in the Northwest, we're still doing better than we've been. This timeline is available each week at the link down there on the lower left, and we also put these out for each county as well, so you can hone in on your area of the state. And again, zoom in, just showing from the start of 2020, which is when this last drought segment got going, so you can just see the latest drought period in a bit more detail. A bit over 45% of Wyoming now has no D category whatsoever, and just over 80% is at D0 or better. And I've changed the little bar down here, so instead of showing the percent remaining of D3, we're now showing 3.64% of the state now in the D2 or severe drought category. I want to jump over and look at precipitation itself. This is a percentile. This is over the last 2 weeks, so it shows 14-day total precipitation as a percentile. You can see the wetness in the east showing up, resulting from those storms the week of the 10th. Put a lot of green and blue and even purple on the map, as well as helping with the drought conditions that were there, as you saw in the previous slides. Unfortunately, you can see the Northwest standing out, which was not as much of a benefactor of those rain events. So we're getting into the very concerning percentiles up here as far as the precip over the last 2 weeks. And pushing the clock back to a 90-day or 3-month window, you can see parts of these showing up wet, where the recent precip is starting to influence even a 3-month depiction. Southwest is also on the wet side, but then we have the concerning area, which is much of the Northwest, the Bighorns down in Carbon and Albany County, and then parts of the Northeast, especially in eastern Weston County up here. Looking at standardized precipitation index, or the SPI, these are showing the index or indices for the 30, 60-day time periods on the top, and then 1 year down on the bottom right. And just recall, These maps are an index. They're not actual precipitation amounts that we're seeing here on the map. So these numbers here are an index and not precipitation values. Some areas of concern emerging in the Northwest, as you'd expect, given the previous slides, along with Northern Natrona and Johnson counties. The Northwest really stands out in that 30-day view, kind of extending over into the Bighorn Basin and then down into Lincoln County. Also some emerging dryness in the far south central reaches as well. Looking back 60 days, the dryness in the Northwest is starting to influence the maps at the 2-month time span as well. And you can see Carbon County showing on the dry side too. It's 60 days on the upper right here though, but especially up here on the 30, you can see the signal of those precipitation events earlier in the month appearing in blue. 1 year on the bottom right here, the winter precipitation is very evident in the south and central areas, and not a lot of concerning areas showing up on the map. We've kind of eaten away at this red that we were seeing at the 1 year time frame down here in the southwest or southeast. So that's a good sign. 14-day, so 2-week average minimum temperature. The minimums over the last 2 weeks. These are actual temperatures here on the upper right are now above freezing, except for the Northwest and the higher elevations, the Bighorns, Medbos, Sierra Madres. Elsewhere, we have 40s to lower 50s as minimum temperatures for most of the eastern plains and the Bighorn Basin, with mid 30s and 40s for the remainder. In terms of departure from average, here on the bottom left, most of the state 3 to 6 degrees above average, a few warmer spots east of the Bighorns and also in Platte and Goshen counties. Also have a few areas as much as 3 degrees below average up in Park and then down in southwestern Sweetwater County, with the rest of the state just being just above average. Switching over to maximum temperature over the last 2 weeks, here up on the upper right, again, actual temperatures. So over the last 2 weeks, the average max temperatures have been above freezing statewide, finally, and the warmest areas being the Bighorn Basin, which had 2-week average temperatures in the low to mid 70s. Other than the high elevations, the lowest highs over the last 2 weeks are about 60 degrees down in the Laramie Valley and a few other assorted spots. Down on the upper or lower left here, we have maximum temperatures. Departure from average, we see the west and much of the Bighorn being about 3 to 6 above average. Some warmer areas up to 9 degrees above average in Teton County. Southeast was the coolest compared to average, with that corner being about 3 degrees below average, and the eastern third of Laramie County as much as 6 degrees below average. The rest of the state, so they're in the middle. Extending up into the northeast was about 3 or so degrees above average over the last 2 weeks. Take a look underground at the soil moisture, somewhat a mixture of improvements and degradations as far as soil is concerned. Western part of the state has deteriorated, especially in the northwest there, which you would expect given those precipitation deficits in that area. The precip that second week of May really improved conditions in the east, although even there, they've deteriorated from where the peak was a few days ago, and we're starting to go back down into to worsening conditions, but definitely a lot better than where we were compared to 2 weeks ago, which is that map there on the left. And snowpack by basin, the snow season is pretty much over, even though we still have snow up at elevation in places. So I want to just give a quick rundown of where we are and how the season was. I've shown this table the last couple of webinars, but this time I've sorted it to show how much snow water equivalent is left. And you can see that a few of the basins are fully melted out there. However, the list here, column 9, there are also 5 basins still with more than 10 inches of snow water equivalent on them. Column 2 is the date of the peak snow water equivalent for this year for each basin, and 9 of the basins had a later than average peak date, and all but 2 here in column 6 showing the actual amount peaked above the median. And of course, that snow, as it comes off, goes into the rivers, which is a really good segue to our next speaker, who is Aaron Fiaschetti with USGS, to give us an update on stream flow conditions. Take her away, Aaron.
That's a great segue, Tony. Well, thank you, Aaron Fiaschetti with the USGS here. And it's nice to have above normal to wet conditions to report on for a change here. So this is a snapshot of Wyoming, and what you'll see here is color coded by percentile. So what they're calling normal here is 25th to 75th percentile. So that's a pretty wide range where it's saying it's normal to be low near the 25th percentile, and it's normal to be wet. So that'd be a higher flow near the 75th percentile. And that you'll see a light blue, which is above normal. That'd be a 76th to the 90th percentile, showing that pretty high stream flow. A dark blue, which is above the 90th. So that would be a very high stream flow. And then we have some black dots that are showing an all-time high for the day. And then we have 2 sites that are showing in minor flood stage. That's the Henry's Fork near Manila in the southwest, and then the Bear River at the below Pixley Dam in minor flood stage. So in general, pretty high flows right now. There's a few gauges in the Jackson area showing a white. That means they're not ranked, but they're those sites pretty similar conditions to what you see around something above the median or above normal. So pretty good flows everywhere around the state. Next slide, Tony. So this is just a duration hydrograph for the entire state. And just the point of this slide is to kind of show us where we are on the hydrograph for the year. So here we are, we're kind of in a time of nearing the peak or past the peak, depending on where your water comes from. If your water's coming from really high alpine mountains, we're probably nearing the peak or maybe a little bit past, depending on the snow melt. And if we get a good rainstorm to really drive those flows, if your water supply comes from the prairie or some foothills, we're probably well past the peak. And that flow is going to be sustained by periodic rain events as they come through. So it's a time of abundant water supply. This is when we fill reservoirs. This is when fields get irrigated, and there's potential for flood during this time of year. So yeah, probably depending on how things shake out, the peak could be anywhere from one to 3 weeks away, or it could be past. So I can't really comment on where we are till it's kind of occurred. So next slide, Tony. So just kind of bumping around the state, looking in the northwest corner, up on the North Fork of the Shoshone. Things have kind of risen pretty high lately. We're much above normal here. So it's kind of getting into that period where we're going to see a peak anytime from now to the next couple weeks. But right now flows seem like they're pretty good. Things look pretty reasonable up there right now. So moving over to the northeast, this is a Belle Fourche. So that'd be kind of an example of where your water supply comes from, not from tall mountains with lots of snow. Things are been in the above the median there, kind of in the green to above normal, probably mostly driven by rain lately here in May. So the water supply looks pretty good there right now. That'll probably continue to be dependent on how abundant spring storms are in the northeast corner for that water supply. Moving down to the Platte above Seminole, above normal here. We're above the 75th percentile, been up above the 90th for a little bit. Some of that could be, it looks like runoff was a little bit early, but it's hard to kind of say for sure when you're looking at a period of record that's 80 years or more, that those peaks can move around quite a bit. But so flows look pretty good where there's abundant water moving in the Platte River right now in that location. And then bumping over to here's one with an all-time record for the day, the New Fork River near Big Piney. Pretty significant amount of water moving through the system right now. Where we are for 2023, that black line is looks like it's a little bit early. We've had some warm weather, but we'll have to kind of see how that shakes out for the season. But right now, abundant water supply in that location. So the Southeast has been kind of a place where we've been pointing to a lot lately of really low stream flows, especially last year. And right now, everything looks really high. So we're on the opposite end of the spectrum. So next slide, please. So I know Liz is going to talk about reservoir storage in more detail, but in general, times of abundant water supply, this is when reservoirs get filled. Almost all reservoirs saw an increase except for a few in the state during the last month or so. But it kind of just looking at that teacup diagram for May 25th, you can still see a fair amount of white in nearly every reservoir. So all the reservoirs kind of have a ways to go before they're full. And that's probably a reflection of a few dry years and quite a bit of storage to be filled, with the exception of management factors also. But that's all I have. Thanks, Tony.
Thanks, Aaron. Now getting into some of those management factors is Liz Cresto with the Bureau of Reclamation. Liz?
Yep, I'm Liz Cresto with Reclamation. I'm the operator on the Bighorn side of things, but we also manage the reservoirs on the North Platte. So let's start talking off about the Bighorn system. The table below shows Bull Lake, Buffalo Bill, and Boise in terms of contents, capacity, percent full, and percent of average. As a system, we're 72% full or 101% of average. All three reservoirs are currently increasing their storage right now with the runoff that's coming in. Next slide shows our forecast. On the left shows our May through July runoff forecast. We do forecasts at the beginning of each month. So June 1st, we'll issue a new forecast, but Buffalo Bill's inflow forecast for May through July was 664,000 acre feet or 94% of average. Boise runoff for that same period was 608,000 acre feet or 109% of average. Currently, releases from Buffalo Bill are 1,800 CFS. Boise, we're releasing 3,000 CFS, and Bull Lake's outflow has jumped up to 800 CFS. Next slide shows kind of our reservoir release plans. At the beginning of each month, we do a 12-month outlook for what we're going to be releasing from the reservoir. And we look at actually 3 plans. The green shows the kind of drier conditions. Red shows the expected conditions, and blue shows kind of a wetter trend. And these are, so starting off with Buffalo Bill, these are our monthly reservoir releases on a monthly time step. So that I like to think of the bars as giving you an idea of the range of possibility of flows during that month. And so for Buffalo Bill, you see in June, stepping up flows a little bit, and then we'll likely fill the reservoir and decrease our flows through July through September, just meeting irrigation demand. That is after refill. So it's kind of similar story for Boise. Our June outlook was 2,000 CFS, but we're up at 3,000 now. That runoff's a little bit early. We're a little ahead of schedule. But we plan on filling Boise and then kind of stepping down flows as the runoff decreases and kind of stepping down into irrigation demand. On the bottom right, you'll see a website you can look at for water order changes, because June is a month where we do often make quite a few changes to our releases. So check that website if you're interested in the flows and what we're going to be doing. Next slide switches over to the North Platte side of things. The North Platte is going off of several dry years. The reservoir system over there isn't quite as flush with water. You'll see the reservoirs as a whole are 45% full or 93% of average. So our April through July runoff forecasts, I think Seminole about 1 million acre feet, Sweetwater above Pathfinder, 70,000 acre feet, and Alcova to Glendo, 110,000 acre feet. So they're in general, it's above average inflows, but because we have so much space in the system, we don't anticipate filling. So Pathfinder will likely not fill this year. Next slide goes into our releases. Seminole Cordes releases are 2,800 right now. Pathfinder releases will be 75 below the dam. Fremont Canyon Power Plant releases will be made to maintain Alcova Reservoir at the summer operating level. Gray Reef releases are about 1,000 CFS. Tomorrow we're going to bump those up by 200 CFS, and then again by additional 200 CFS on Saturday. Glendo and Guernsey are both releasing 2,400 CFS, but we anticipate those Guernsey releases are made to meet irrigation demand, and we're expected releases from Guernsey to go down to around 900 on June 2nd. And then there's the reservoir operating plans. So Semno, starting off at the upper left, June releases are around that 2,500 CFS, June, July, in August, before stepping them down towards the end of the irrigation season. Gray Reef will likely increase our outflows from Gray Reef up to about 3,500 CFS, and then stepping them down through the irrigation season. And then Guernsey releases are anticipated to be around that 2,000 CFS for June, and then up around more like 4,500 to 5,000 CFS July and August, and then stepping it down in September. I think that's all I have for our reservoir conditions. Thank you, guys.
Thanks, Liz.
Thanks.
And now I'll turn it over to Lance Vandenboger with the National Weather Service in Riverton to give us an update on weather forecasts and outlooks. Lance?
All right. Thank you, everyone, for tuning in. First, we're going to look at precipitation over the next 7 days. You can see there that green colors denote anywhere from just a trace of precipitation all the way up to ½ inch. And in general, south central parts of the state are expected to get the least amount of precipitation with this pattern that we're in. The next several days are going to be showery and widespread to numerous showers. But the eastern parts of the state and the mountains are going to be the big winners from that day after day afternoon convection. I did put a little note here just to describe and maybe teach a little bit about weather. When we say convection versus stratiform, convection is more like thunderstorms that are hit or miss in nature. When you get the big spring cloudy days that you have rain all day, that's more stratiform rain. So this map, although it shows widespread precipitation, is based on several days of accumulated convective rain. Some places will inevitably miss out on these thunderstorms and showers, and it won't be quite as smooth when we look at it after the fact as compared to maybe a big weather system that moves through and the whole state gets wet. That's not going to be the case this time, most likely over the next 7 days. But at any rate, the eastern part of the state is looking like it will get the most amount of precipitation, with anywhere from ½ inch all the way up to maybe an inch plus in some locations, shown by those brighter blues and purple colors. All right, and then we're going to go ahead and step just a little bit further. So if we go to the 6 to 10 day outlook, which is May 30th through June 3rd, you can see that the overall weather pattern favors above normal conditions. Not 100% chance, but very confident that the northern part of the state is going to be above normal. Normals this time of year obviously vary based on elevation, but run anywhere between the upper 60s to upper 70s, depending on where you are in the state. So that's just a sense for what we mean when we say above normal. So the northern part of the state looks like almost a sure thing to be above normal during the next that May 30th to June 3rd timeframe. If we go over to precipitation, not quite as strong a signal, but the southwest corner of the state is looking pretty likely to be above normal for moisture. And the whole state does lean towards wetter than normal rather than drier than normal. So with streams flowing high, there could be localized issues, especially if some of those thunderstorms go right over an area that's already experiencing high flows. That will just make things worse. So something to consider over, especially through the weekend here. As we look ahead. All right, now we're jumping a little further in time, looking at the 8 to 14 day outlook. This would be June 1st to the 7th. Above normal signal remains. So overall, the pattern looks to remain pretty persistent in that the northern part of the state is likely above normal. There's a lean towards above normal temperatures, even for the southern half of the state. And if we look over to precipitation, that looks very similar as well. We are going to remain in a pattern that's favorable for afternoon showers and thunderstorms, even into next week, likely, with a low pressure sitting just to our west and south. That's going to be directing a lot of moisture up over Wyoming. So that's why we're kind of staying in that pattern. If we go a little further ahead in time, here's a 1 month outlook. So once we start talking about the 1 month outlook, we're no longer explicitly modeling what's going to happen weather-wise. It's more looking at the global weather patterns, things like El Nino and La Nina, and trying to get correlate that with what normally happens in either of those scenarios. If we look at temperatures, there is no clear global weather pattern signal. So that Wyoming show up in white, it actually still does tell you something. It just tells you that near climatology is your best forecast. So you have an equal chance of being above and below. When we look at precipitation, there actually is enough of a signal to at least say a slight lean. You know, if I were a betting person, I wouldn't necessarily bet off of, just a 33 to 40% chance compared to a 33% chance. But there is a slight lean, especially in the southeastern part of the state where and maybe we get a little bit more moisture in that June timeframe. If we step ahead one more, I believe this will be the last slide here. This is the 3 month outlook. So again, looking at those global, across the globe climate conditions, weather conditions, we move into leaning toward above normal for temperatures, especially for the southwestern half of the state. The signal's not quite as strong for the northeastern half of the state. And then if we look over to precipitation, we go back to equal chances. So again, that doesn't mean that nothing's going to happen, but near climatology is your best forecast. All right, and I think that wraps it up for the local forecast office side of things.
Well, thanks, Lance. And now we have Paul Miller with the Colorado Basin River Forecast Center to talk about flood potential.
Great, and thanks, Tony, and thanks, Kevin, for letting me get in on your spot here this time around. I don't think flood potential has really changed since the last time this webinar and this meeting was held. Most of the flooding potential is focused in on the western and southern portions of the state. Currently, we're observing flooding along the North Platte River, the Salt River right at the border, the western border of Wyoming, and the Bear River in the southwest corner of the state. There's some areas with concern with the Green River, the Encampment River, the Wind River, and Pacific Creek, all generally kind of in the southern portion, southwestern portion of the state. In general, we're just seeing with the above average snowpack and with the snow melt really starting to get going, especially at higher elevations. We're seeing above normal stream flows pretty much everywhere. So even though that, official flood stages might not be being reached, above normal stream flows are pretty apparent nearly everywhere. If you'd like some more specific information, I'm happy to help. There's also a lot more information on the River Forecast Center pages. I put the Colorado Basin, Northwest, and MBRFC links there. And happy to help if there's any other questions.
All right, thanks, Paul. And now with our highlight of the month, we have Scott Whiteman with the USGS to talk about streamflow measurements in gauge to page.
Awesome. Thank you, everyone, for inviting me. Thank you, Wendy. Thank you, Tony, for inviting me to do this. Thank you, Aaron, for reminding me. But it's just, being able to how do we get data to end data users and overall water users, water managers? But there's just, you know, neat little picture there, use of our new RC boat for collecting ADCP measurements. And it's at an area where I typically wouldn't be able to wade something like that, 6 feet deep at the outlet of Quake Lake, just north of Yellowstone. And there's, you know, one of the good old boys back when they didn't care too much about safety, making a cableway measurement. So next slide, please. Here's kind of our current data deliverable. And looking at the instantaneous value data or unit value data, as some people call it. And this is just a graphical and tabular type representation of the data. We do realize the little bit of clunkiness in our new web page. We apologize for that. There are improvements currently being made. Currently, we still are maintaining the legacy web page. So feel free to click on the legacy web page link to access data, and it looks in a familiar format that you have. Next slide. And this is just a quick overview looking at our current Wyoming, Montana Water Science Center data collection activities and in the two states there. This isn't a recent screen grab, just more showing location and, you know, coverage of our data collection activities. Next slide. Which feeds into a much larger model, which is the National Water Dashboard that is put together. And you can, the nice thing about the water dashboard is you can you can overlay weather conditions, so precip, wind speed, cloud coverage, whatever. It's great for using in, you know, for field trip planning on our level. It's great for water managers planning, looking at, you can get a visual representation of what's going on there. There's precip coming in the next couple of days. You can ramp back irrigation. Next slide. Well, how do we get the data to the users? And this is just a rough schematic of a normal GOES or geostationary operational environmental satellite system there, where you get a gauging station, transmits up to a satellite, comes back down to a command and data acquisition, goes back up to a domestic satellite, and comes back down to a local readout ground station, where both the National Weather Service, Bureau of Reclamation, and the USGS all grab that data and begin processing it, and we can show it live on our NWS web. Next slide. This is just kind of continuing on with kind of newer practices of how we're grabbing that. Is we go grab it from that downlink, the EDN downlink there highlighted, goes up onto the cloud where we process that information, aquatic informatics, and that's just a graphical representation of somebody processing data in Aquarius, so we can go live with it on NWS web. Next slide. But this is just, well, how do we actually get it there? Well, so what's actually being transmitted via the GOES satellite is, in most cases, we've switched a lot to ASCII. And so you can see the ASCII text being transmitted via GOES transmission, and we go grab that, and through a process that we call decodes, which we're currently swapping over to our DCAP system, processing that to show up there as gauge height in NWS web. And it's like, well, a lot of us are interested in Streamflow, so let's go next slide. Is how do we process that data to get you Streamflow? We've got our stage record coming in. We got gauge height corrections being applied to that. We have Streamflow discharge measurements. We apply shifts to our rating model, and then we compute the discharge. And of course, there are times where not everything's working right. We have missing data, or we need to estimate record due to backwater conditions or some odd condition that may be out there. We do some produce hydrographs and finally publish that instantaneous value data. Next slide. This is just, you know, kind of the general process. You can see the raw being represented in a green line there, corrected data in blue. But we want to go in and look at to see if there's any data gaps, delete any erroneous data, apply gauge height corrections based on what we're finding out in the field, and then document those findings in either some kind of station analysis or on our new records process there. At least what you're doing there is in your edit history. We want to document both to yourself and to somebody that's going to come back and review that data, the logic and the process you went through in correcting your data. Next slide. And this just highlights, going back to the schematic up there, the streamflow measurements and the different methodology of doing so. We have our traditional methods over on the left over there, which we commonly revert back to. I would suggest the gentleman there in the upper left were a PFD. But we've progressed to making, for the most part, I just said it on a webinar about an hour ago, that over half of our measurements are being made with hydroacoustic technology, with a flow tracker kind of near the red line there, and a wide variety of ADCP technology that's out there for making either a tethered or a fixed boat mount like you see in the bottom. And that's just kind of, goes into our data collection effort and getting that data to you. Next slide. This is just, what's a streamflow measurement? I'm not going to go into great detail. There's yours truly hanging over a river, and then just a graphical representation of what's happening underneath with that data there collected using 4-beam or 9-beam technology to process depth, velocity. The unit can track itself either via bottom tracking or GPS technology. And then there's just another schematic of a person making a wading discharge measurement using a midsection method, which was developed and widely used by the USGS and accepted by and is implemented by other agencies. Next slide. Here's just an example of your basic stage discharge relation, also known as a rating model. We typically plot it, oddly enough. We got our independent variable plotted on the vertical axis, and then our dependent variable plotted on the horizontal axis. In log space, it actually plots very nicely, and I won't go into great detail of why we plot it in log space, but if we plot it in log space, we can typically look at straight line segments of our rating as represented here. Next slide. This is just, this was supposed to say shifts. It didn't save yesterday. I was having internet connection. But this is just, basic shifting to your rating model. Upper left is showing, heavy algae effects that would affect your stage discharge relationship model, where, your stage would increase, but your flow would maintain the same. So we have to correct for that, as indicated by the pink line on the bottom graph, both lines there. Similarly, you have a tree on your controlling feature there downstream of your stage sensor that would also be affecting your stage discharge relationship. And then, of course, we have our dreaded sandy channels, which some of us are very familiar with, sometimes in Wyoming, that our stage discharge relationship is constantly changing based on migration of the channel and the fine sediments moving through there. Next slide. This is just kind of goes through the process of, real quick snapshot of our record analyzing and approval process. We go on, we analyze the stage record, we apply shifts to it, we document within the system our logic, and then we go back after the fact and explain in an analysis format how we compiled that information, which is shown on the bottom right. Next slide. Just highlighting some of our newer data retrieval using cellular modem technology or Iridium, and actually cellular is cheaper, so that's the option that we typically go with. Is we have a data logger that's sitting out there logging data at a specified interval, and it's literally just listening, and we go out with a script and ping this using an IP address, and it's protected, it's a VPN, it's a protected network that we go out and grab this information on. But I can literally program the instrument or go grab data from it at any specified interval. But you can listen live on the unit and see, talk to it. This is me talking to a unit up by Glendive, sitting in the comfort of my desk here, analyzing what's the signal strength out there, what's the latest reading that's out there, and then comparing that to what we're presenting on our would-be new web page out there. Next slide. So this just goes into, and I won't go into great detail, what comes with the USGS Streamgage. It's just the QA/QC that's gone through, the continuity, and that there's national, that we're all operating the same guidelines. You can take me, put me in New Hampshire, although the site characteristics might be different. I'm going to go through the same procedures and guidelines as I would if I was collecting data here in Montana or Wyoming. The data is archived and publicly available. So when data requests come in for historical data, we can provide that to data users. There's typically accurate and continuous data. We monitor data on a daily basis, if not hourly basis, if it's flooding, to make that data publicly available and continuous. There's cooperative approach with the state and local entities that we partner with. A lot of folks, there's a common misunderstanding that we have a lot of directly appropriated dollars going to collection of Streamgage monitoring stations, and we actually do not. So there's a lot of cooperative agreements we enter with state and sometimes even one agency or one entity. So next slide. This is just just a plug for the National Weather Service. They're great advocates for the USGS stream gauging program, and they also provide a tool that I personally use as a flood coordinator, and their flood forecasting, which helped us this spring up along the Milk River as ice busted loose during a period going from 40 degrees up to close to 90 in a matter of a couple of days. And that's Milk River at Tampico there. That's the site conditions that the hydrographer was presented. But here's the the forecast, and then just a graphical representation of our Streamflow hydrograph dotted with measurements made over that peak to refine the amount of discharge going by. But with that, I think that's it for me. Are there any questions? Thank you, Lance, for the link I saw pop across there.
All right, thanks, Scott. Always good to see some of the inner workings of how those data get out there for people to grab and use. So with that, I'd like to thank the fellow presenters who are all shown up here on the slide, and I will now turn it over to Wendy Kelly, who will take us into Q&A.